Hello everyone, my name is Himanshu Sharma and I welcomes you on India's greatest learning platform, Utkarsh classes. As you know, today we are going to discuss a very important topic of reasoning, that is your figure calculation. But before starting our topic, please first like and share this session as soon as possible. As you know, this is related to your non-verbal part. In a previous class, we have discussed that reasoning is classified in three parts: verbal, non-verbal, and logical. And this topic is related to your non-verbal reasoning. In the last class, we have discussed the coding decoding, that is, the topic is related to your verbal reasoning. Now, today we are going to discuss a figure calculation, and this topic is related to your non-verbal reasoning. Non-verbal reasoning means the questions or the topic that is related to your diagrams. In this topic, we are going to count different things like number of lines, number of triangles, number of rectangle, number of squares. There are different things we are going to calculate or we are going to count in this figure calculation topic. So we are going to start this topic. Now, what things we will consider in this topic? In counting of figures, so in counting of figures, we will learn about counting of straight lines, counting of straight lines, plus second, counting of squares, third, counting of rhombus, fourth, counting of rectangle, fifth, counting of parallelograms, sixth, counting of diagonals, seventh, counting of triangles. That will be very important in this counting of figures, counting of triangles, which is very important, and eighth, counting of circles. So basically there are 8 different figures we need to count in this topic, that is your counting of figures. And now we are going to start this chapter with counting of straight lines. Counting of straight lines. So first, case first, or we can say type first, is your counting of straight lines. Counting of straight lines. So in this particular topic or in this segment, what we are going to do, we need to count how many straight lines are required to draw this figure, or we can say how many minimum number of straight lines are required to draw the given figure. So basically examiner will ask question in this form: number of straight lines, number of minimum straight lines required to draw given figure. Minimum number of straight lines required to draw given figure. Now we are taking one example, like So we need to count how many straight lines are required to draw this figure. Now if we are talking about the number of straight lines, so we need to count straight lines in three different things, or we need to consider the three different things. That will be your horizontal line, vertical line, and inclined line. Or we can say the given diagram can be divided in three parts: horizontal lines, vertical lines, and inclined line. One more thing we need to understand. For example, if this is a straight line and one more straight line is drawn in this way, this is the first straight line and second one is drawn in this way. So if we are going to count this, or if we are going to count the straight lines, so we will consider this line as a single line, not in two parts. This one and this one is not a different straight line, because this straight line having the same slope, having the same slope. And if a straight line having a same slope, it will consider as a single straight line, not a different straight line. But if this and this, or we can say if this type of figure is given, so we will say to draw this figure only two straight lines are required. But if we draw the straight lines in this way, so how many straight lines are there? So you can see this straight line and this straight line, this L1 and L2 having different slope. And what is the meaning of slope? Slope means a angle made by a line with positive x-axis. An angle made by straight line with positive x-axis. That is called, or we can say we are taking the tangent of that angle, that will called slope. So what is the slope of a straight line? If we are taking a tangent means tan theta. If we are taking tangent of a theta, and theta is what? An angle measured with the positive x-axis. So we are taking a tangent of an angle that is measured with the help of positive x-axis. So that tangent of this theta is known as slope. And if this line and this line, L1 and L2 having different slopes, so it will consider as a two different lines. This one and this one will be two different lines. Okay, so we need to count in this figure how many straight lines are there. So as I told you, we need to divide this figure in two parts or three parts. That will be your inclined, vertical, and horizontal. H stands for horizontal lines. V stands for vertical lines, and I stands for inclined lines. Horizontal, vertical, and inclined lines. Okay, so now we are going to start the counting of straight lines. First we are going to count the horizontal lines. So how many horizontal lines are there? So starting with this topmost, this one is your first straight line, this one is your second straight line, and as I told you, this line will consider as a single straight line, not two, or not we will not consider as a two straight lines, because this line having same slope, so it will consider as a same single straight line. So first straight line, first horizontal line is this one. This one is your second, third, fourth, fifth, sixth, and seventh. So we can say in this figure total 7 horizontal straight lines are required. Now we are going to consider the vertical lines. How many vertical lines are required to draw this figure? How many vertical lines are required to draw this figure? So as you know, we are going to count the vertical lines. So starting with the leftmost, this is your first, second, and this will consider as a single straight line. This will your third, this one fourth, fifth, and this one is your sixth. So total 6 vertical straight lines are required. Now if we are considering the inclined lines, so in this figure there is no such inclined lines is there. Inclined line means if we are drawing a line at some angle which is not equals to 0 or 90 degree, that will consider as a inclined line. So there is no inclined line is there. So we can say in this figure only vertical and horizontal lines are there, 7 horizontal, 6 vertical, and inclined is 0. So total how many straight lines are required to draw this figure? So if we added all these things, so 13. So 13 straight lines are required, or we can say 13 minimum straight lines are required to draw this figure. How many straight lines are required to draw this figure? 13 straight lines are required to draw this figure, or we can say 13 minimum straight lines are required. So now I hope you understood very well how to count the straight lines. So we need to divide the given figure in 3 parts: horizontal lines, vertical lines, and inclined lines. And one by one we need to count all these things, and at the end we need to add all these numbers, and we will get how many minimum straight lines are required to draw this figure. So I hope you understood very well. Now try to count how many straight lines are required to draw this figure. How many straight lines are required to draw this figure? So how many straight lines are required to draw this figure? So I am giving you 1 minute for this question. Try to count. Hurry up. Only 20 seconds remains. So, as I told you earlier, we need to classify, or we need to divide this given figure in 3 parts. That will be your horizontal, vertical, and inclined lines. So, first we need to count horizontal lines. How many horizontal lines are there? So, this one is your first, this one will consider as a second horizontal line, and this one is considered as a third straight line. So total how many horizontal lines are there? Total 3 horizontal lines are there. Now we need to count the vertical lines. Vertical line, that line makes 90-degree angle with positive x-axis, is known as vertical line. Horizontal line, that line makes 0-degree angle with positive x-axis, is known as your horizontal line. Okay, so there are 3 horizontal lines. Now we are going to count the vertical lines. So how many vertical lines are there? So you can see this one and this one. So total there are 2 vertical lines are there. Now we need to count inclined lines. So there are several inclined lines are there. One by one we need to count. First we are going to count the inclined lines that originate from this point. So this one is your first inclined line, this one is your second inclined line. No need to count this line because already considered in a horizontal line. This one is your third, and this one is your fourth. So that lines originate from this point, and that kind of inclined lines are there 4. Now remaining horizontal or remaining inclined lines are there. You can see these are not considered in this 4 lines. So first and second. So other than 4 there are 2 more inclined lines are there. So total how many straight lines are required to draw this figure? So 3 to 5, 5 plus 4, 9, 9 to 11. So 11 straight lines are required to draw this figure. how many minimum straight lines are required to draw this figure? 11 minimum straight lines are required to draw this figure. I hope now you are able to understand this thing very clearly, that how to count horizontal and vertical and inclined line also. Now in the next question, try to figure out how many straight lines are required to draw this figure. Find number of minimum straight lines. Number of minimum straight lines are required. Number of minimum straight lines are required in this figure. So I'm going to draw this figure. Find how many straight lines are required to draw this figure. Giving you 90 seconds to figure out. So try to divide the given figure in 3 parts and one by one count horizontal, vertical and inclined lines. And as I told you, if two straight paths having different slopes, then in that case these paths will consider as a two different straight lines. Remember this thing during counting. So now try to figure out how many straight lines are there to draw this figure. So first we are going to count the horizontal lines. So how many horizontal lines are there? So starting from the topmost, first, second, third and fourth. So total there are 4 horizontal lines are there. Now we are going to count the vertical lines. So how many vertical lines are there? So this one is your first, second, third, fourth and fifth. So total 5 vertical lines are there. Now how many inclined lines are there? So how many inclined lines are there? So now we are going to count inclined lines. From this point there are total 1 and 2. 2 inclined lines are there. And as I told you, this part and this part having different slope. So this part and this part will consider as a two different straight lines. Understood? So again, from this point there are 2 straight lines. From this point there are 2 straight lines. So 2 plus 2. Now we are going to count these inclined lines. First, second, third and fourth. So these are also considered as a straight line and 4 different straight lines. So total 8 inclined lines are there in this figure. So now if I add all these numbers, so total 17 minimum straight lines are required to draw this figure. Now I hope you understood very well. So total 17 straight lines are required to draw this figure. So now we are taking one more question and then we will move to the next part, that will be your counting of squares. Question number 4. Find minimum number of straight lines, are required to draw this figure. To draw this figure. To draw this figure. Okay. So So how many straight lines are required to draw this figure? How many straight lines are required to draw this figure? How many straight lines are required to draw this figure? This one is your single straight line. This one is your a single straight line, okay? So as I told you, we need to divide the given figure in three parts: horizontal, vertical, and inclined. And at the end, we need to add all these numbers, and it will give you total number of straight lines required to draw this figure. Okay. So giving you 60 seconds to count. So I can say this is the very simplest type of this counting of figure, in which basically what we need to do, we need to count the straight lines required. And I think after these 4 examples, there will be no such kind of problem or no such kind of difficulty will be there in counting of straight lines. Okay. So you can count number of straight lines in any type of figure. Okay. So starting with horizontal lines, how many horizontal lines are there? So this one is your first horizontal line, first, second, and third, and this is your fourth. So total how many horizontal lines are there? Total 4 horizontal lines are there. Now how many vertical lines are there? So there is no such vertical line is there. You can see there is no such vertical line is there. So 0 number of vertical lines. Now we are going to count the inclined lines. So there are 2 types of inclined lines. First one is in such way, and second one in such a way. So first starting with this is your first, this is your second, and this is your third. So three inclined lines are there. And now if we are considering these type of inclined line, so first one, second one, and third one, and fourth one, because you are able to see there is no connection between these 2 points, so there is no inclined line, so if we are counting the black inclined lines, only 3 inclined lines, but if we are counting the blue inclined lines, so there will be 4 inclined lines, because this is also considered, this is also you can say these 2 points are also connected with the help of straight lines, so we need to consider this line also. So total how many straight lines are there? So we can say 4 plus 4, 8 plus 3, so total 11 straight lines are there. Total 11 straight lines are there. Okay, so 11 straight lines are there. So to draw this figure, how many straight lines are required? Total 11 straight lines are required. So now I hope you understood how to count number of straight lines required to draw the given figure, and you can count very easily. Now we are moving forward for type second. In this type, we need to count, or we need to understand, we need to get an idea about how to count squares, counting of squares. Counting of squares. Counting of squares. Now, before giving an idea or before giving you any trick about counting of square, if I am giving you a figure, so try to figure out how many squares are there in this figure. So if I am not giving you any type of trick, so you need to count number of square by conventional method. So conventional method says what? We need to consider all squares, or we need to count all the squares one by one. So we are starting with the smallest square of this size. So how many squares are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. So the smallest squares, how many squares are there? Total 9 squares are there. Now we need to consider the bigger square with respect to this smallest. So this one is your second largest. Second largest. So how many squares are there? So if we consider these square, first one is your this first. This is your first one. This is the second one. This is the third one. And this is your fourth one. So now I hope you are able to figure out these type of squares. These type of squares. So total how many squares are there? Total 4 squares are there. And now we are going to count the biggest square, that is your, so you are able to see this thing. This is only one. So total how many squares are there? 9 plus 1, 10 plus 4, 14. So total 14 squares are there in this figure. Now we are going to discuss a trick. Now how to count number of square in that type of figure in few seconds. So what we need to do, we need to check how many small squares are there in horizontal line and how many, or in horizontal line, and how many small squares are there in vertical line. So if you consider number of smallest square in horizontal line, so you are able to see 1, 2 and 3. So total 3 horizontal smallest square are arranged in a horizontal line. Now similarly, how many smallest squares are arranged in a vertical order? So you are able to see 1, 2 and 3. So 3 vertical squares are there, or 3 smallest squares are arranged in a vertical order, and we need to write these 3 into 3. So number of smallest number of smallest square in horizontal order into number of smallest square in vertical order. Okay, starting with 3 into 3. Now we need to reduce 1 from these two number, and you will get 2 into 2. Now again we need to reduce 1 from these two number, you will get 1 into 1. And now if you reduce 1 from any of these, you will get a 0. So if you are getting 0, we need to stop. Now multiply these numbers, 3 into 3, 9, 2 into 2, 4, and 1 into 1, 1. And add all these numbers, and you will get 14 squares. So in this figure, how many squares are there? Total 14 squares are there. All type of squares, like small, bigger, biggest, all squares are considered in this 14 squares. So this is the trick by which we can calculate number of squares in that type of figures. Understood? Understood? Now I am giving you one more example. Try to figure out number of square in this given figure. Number of square in given figure. Number of square in given figure. Now try to figure out how many squares are there in this figure with the help of the given trick in a previous example that we have discussed. In a previous example, using this trick, you need to find how many squares are there in this figure. I am giving you 60 seconds to figure out. Thank you so much, Rahul and Prashant. So time up, guys. Let's see how many squares are there. As I told you, we need to count number of smallest square in horizontal order and number of smallest square in vertical order. So number of smallest square in horizontal order, so you are able to see 1, 2, 3, 4, total 4 horizontal, or we can say total 4 smallest square are arranged in a horizontal order. Similarly, how many squares, how many smallest squares are arranged in a vertical order? So 1, 2, 3, 4, total 4 smallest squares are arranged in a vertical order. So 4 into 4. Now we need to reduce 1 1 from both these number. So we will get 3 into 3. Now repeat this process. If we reduce 1 1 from these two number, we will get 2 into 2. Now again repeat the same process, we will get 1 into 1. Now if we reduce 1 from both of these, or one of them, you will get 0. So we need to stop here. And now multiply all these number, you will get 16 plus 9 plus 4 plus 1. So total how many squares are there? Total 30 squares are there. Total 30 squares are there in this figure. Total 30 squares are there in this figure. Now one question comes in our mind. What if number of smallest square in horizontal order and vertical order are different? So the same trick will work or not? So my answer is yes, the same trick will work in such kind of figure also. So now we are taking one more example having different number of squares in horizontal and vertical order. So we need to find how many squares are there in this figure. So we need to find how many squares are there in this given figure. So as I told you, in this particular example, the number of smallest square in horizontal and vertical order will be different. So try to find how many squares are there in this given figure. Again, as I told you, the same trick will work here also. I am giving you 60 seconds, so try to figure out how many squares are there. So time up, guys. Let's see how many squares are there. So as I told you, the same trick will work here also. So how many number of smallest square in horizontal order? 1, 2, 3, 4, 5 and 6. So 6 into number of smallest square arranged in a vertical order. 1, 2 and 3. So total 3 smallest squares are arranged in a vertical order. Now we need to repeat the same process. We need to reduce one number from both the numbers 6 and 3. So we will get 5 into 2. Now again we reduce 1 and 1. So it will become 4 into 1. Now if I reduce 1 from these two numbers, so 4 will become 3, but 1 will become 0. And as I told you, if one of them is become 0, we need to stop. If both become 0 or one of them becomes 0, we need to stop. So we stopped here and we need to multiply these numbers. 6 into 3, 18, 5 into 2, 10 and 4 into 1, 4. So total 32 squares are there in this figure. So total 32 squares are there in this figure. So now you are able to count number of square in such type of figures if having same number of square in horizontal and vertical order, or having different number of squares in horizontal and vertical order. Now try to figure out number of squares. Try to figure out number of squares in chessboard. Number of squares in chessboard. How many squares are there in chessboard? So first, you need to think about that chessboard having what kind of size? 8 into 8, 7 into 7, 6 into 6, 9 into 9. So first you need to consider, or you need to check, or so chessboard having a size of 8 into 8. Chessboard having a size of 8 into 8. Chessboard having a size of chessboard having a size of 8 into 8. 8 into 8 means number of smallest square in horizontal order is 8 and number of smallest square in vertical order is also 8. Now, starting with 8 into 8, then we need to reduce 1 from both the number and repeat the same process again and again till 1. So you are able to see that we need to add this multiplication, or we can say 8 square plus 7 square plus 6 square plus 5 square plus 4 square, 3 into 3, 2 into 2 and 1 into 1. 3 square, 2 square and 1 square. One method is that you can find out the squares of different numbers and then you can add all these numbers. There is one more method. We can use a formula of your maths. Sum of square of n natural numbers. Sum of square in number system, you will study about this formula. Sum of square of n natural numbers. Sum of square of n natural numbers. So 1 square plus 2 square plus 3 square until your n square. So it is given like this, summation of n square. Here n starting with 1 to n. Okay, and it is given as n plus 1, 2n plus 1 by 6. So whenever we need to find the sum of n natural numbers squares, so we can use this formula directly. So now here n is equals to 8. So directly with the help of formula you can write n equals to 8 8 plus 1, that will be 9. 8 plus 1, 9. At 8 into 2, 16 plus 1, 17, divide by 6. So you can cut these numbers. 2 3s are, 2 4s are, 3 1s are, 3 3s are. Okay, and if you multiply these numbers 17, 4 and 3, you will get 204. So how many squares are there in chessboard? So total 204 squares are there in chessboard. Thank you so much, Economy Adda. Please like and share this session. If you are loving this session, please like and share. So total how many squares are there? Total 204 squares are there in chessboard. So now you are able to understand this thing very clearly, how to count number of square in such kind of figures. If it having same number of square in horizontal and vertical order, or it having different number of square in horizontal and vertical order, you can count very easily. Now we are moving forward. And we are going to discuss the third part, that is your counting of rhombus. So as you know, we studied about counting of straight lines, we have studied about counting of squares. Now we are going to study about counting of rhombus. So counting of rhombus. So first question comes in our mind, what is rhombus? What is rhombus? Type number 3, counting of rhombus. Counting of rhombus. So what is rhombus? So good evening, Sonam Vishnu. So counting of rhombus. So first question comes in our mind, what is rhombus? So rhombus is a type of quadrilateral, square is also type of quadrilateral. So first I think we need to study about the types of quadrilateral. So you will easily able to figure out that which figure having 2 opposite sides are equal, which figure having 4 opposite sides are equal. So types of quadrilateral. This is a special note about the quadrilateral, because we are going to count number of rectangle, parallelogram, square, rhombus. So I hope you need to differentiate all these figures. So we need to understand an idea about types of quadrilateral. As you know, quadrilateral is a what? Quadrilateral is a polygon having 4 sides, a closed figure having 4 sides. Okay, quadrilateral is a polygon having 4 sides. You are able to understand this thing. Now types of quadrilateral, the first one is your square. So in square all 4 sides are equal. In square all 4 sides are equal. All 4 sides are equal. Okay, and second one, each interior angle is equals to 90 degree. If a figure satisfying both these conditions is known as your square. Now second one is your rhombus. So in rhombus, like square, all 4 sides are equal. In rhombus also 4 sides are equal. All 4 sides are equal. In rhombus, all 4 sides are equal. All 4 sides are equal. But the difference from the square is that each interior angle is not equals to 90 degree. each interior angle is not equals to 90 degree. So this angle is not equals to 90 degree. That kind of figure is known as your rhombus. So rhombus is same as square, but difference is what? Interior angle is not equals to 90 degree. Now, third one is your rectangle. Third one is your rectangle. So in rectangle, we can say opposite sides or pair of opposite sides are equal. Pair of opposite sides are equal. All four sides are not equal. Pair of opposite sides are equal. Pair of opposite sides are equal. Second one, each interior angle is equals to 90 degree. Each interior angle is equals to 90 degree. So in a rectangle, pair of opposite sides are equal, and each angle is equals to 90 degree. So this angle is equals to what? 90 degree. All these angles are right angle. And a square, all these interior angles are 90 degree. Okay, so this is your rectangle. Now moving forward, the fourth type of quadrilateral, that is known as your parallelogram. So parallelogram is also same as rectangle, but difference is what? Each interior angle is not equals to 90 degree in parallelogram. So in a parallelogram, this is your parallelogram. Opposite sides, or we can say the pair of opposite sides are equal as rectangle. Pair of opposite sides are equal, but difference is what? Each interior angle is not equals to 90 degree. Each interior angle is not equal to 90 degree. There is one more type of quadrilateral, that is known as trapezium. In trapezium, one pair of straight lines is parallel to each other and other pair is intersecting. In trapezium, one pair of straight line are parallel to each other, and second one is intersecting. For example, you are able to see this figure. So in this figure, A, B, C, D. So in this figure, AB is parallel to CD. AB is parallel to CD, and AD and BC are intersecting. AD and BC are intersecting. ये है आपका cross means intersecting. Intersecting means they are intersecting at a single point, or they will cut each other at a single point. Okay, so you are able to see if I extend AD and BC in such a way, so they will cut each other at a single point. So one pair is intersecting and other one is your parallel. So that kind of figure is known as your trapezium. So this figure is known as trapezium. So basically now you are able to see this thing very clearly. So if we are classify quadrilateral, so basically there are 5 types of quadrilateral: square, rhombus, rectangle, parallelogram and trapezium. And we have understood how to count squares. Now we are going to count rhombus. So as you can see, rhombus and squares both are same. Rhombus and squares both are same, but the difference is what? Each interior angle is 90 degree in case of square, and each interior angle is not equals to 90 degree in case of your rhombus. So the counting of rhombus is same as the procedure of counting of rhombus is same as counting of squares. Okay. So now counting of rhombus, so I can write this note. The process of counting of rhombus is same as the process used in counting of a square. So now if examiner asking how many rhombus are there in this figure, so first thing you need to observe that this time I tilted this figure. Otherwise you will get squares. So I tilted this figure, and now I am asking how many rhombus are there in this figure. And as I told you, the process of counting of rhombus is same as the process that we used in counting of squares. So we need to consider how many smallest rhombus are arranged. Now this is not a square. If someone is asking how many squares are there, if someone is asking how many number of squares are there, so my answer is what? Number of squares will be 0. There will be no square is there in this figure, because these two lines are intersecting each other at other than 90 degree. So there will be no square will formed. So number of square will be 0. But he is asking number of rhombus. So we need to use the same process that we used in number of squares. So we need to consider, or we need to count how many smallest rhombus are arranged in a horizontal order and in vertical order. So you are able to see 1, 2, 3, 4. Total 4 horizontal smallest rhombus are there, and total 1, 2, 3, 4. Total 4 smallest rhombus are arranged in a vertical order. And then we need to cut, or we need to subtract 1, 1 from both these number. We will get 3, 3, and repeat the same process 2 into 2 till 1. So 16, 9, 4 and 1. So you will get 30. So 30 rhombus are there. But again I am repeating the same thing. If someone is asking how many square are there in this figure, so my answer is 0. So now you are able to understand that the counting of rhombus is same as counting of squares. Understood? Now moving forward. So taking one more example, find number of rhombus in given figure. 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 So try to figure out how many rhombus are there in this given figure. I am giving you 90 seconds to figure out. So try to figure out how many rhombus are there in this figure. So as I told you, we need to use the same procedure, same process that we used in counting of squares. So how many smallest rhombus are there in horizontal order and vertical order? 1, 2, 3, 4, 5. And now how many smallest rhombus are there in vertical order? 1, 2, 3. So 5 into 3. Now reduce, or we can say subtract 1 1 from both these numbers, so you will get 4 into 2 and 3 into 1, and we need to stop here because this 1 will become 0. This 1 will become 0. So now multiply these number, 15 plus 8 plus 3. So total will become 26. Total will become 26. Okay, so 26. So total how many rhombus are there in this figure? 26 rhombus are there. Now I hope you understood how to count a rhombus also. So now moving forward for the type number 4. Type number 4, that is your counting of rectangles. Counting of rectangles. Counting of rectangles. Before starting counting of rectangles, you need to understand this thing also. A square is also a rectangle, because square is also satisfy the definition of rectangle. Square is also satisfy the definition of rectangle. So that's why in counting of rectangle we need to count square also. So in counting of rectangles, counting of rectangles, squares also included. Squares also included. Okay, this thing clear? Now I am giving you one figure. And without discussing any trick, I am asking that how many rectangles are there in this figure. Let's try. How many rectangles are there in this figure? I am giving you 90 seconds to think about or figure out how many rectangles are there in this figure. As I told you, squares are also considered as a rectangle because squares satisfied the rectangle definition. What is the rectangle definition? Opposite two sides are equal and each each interior angle is equal to 90 degree. In square, all four sides are equal, so we can say this same line in such a way that opposites pair are also equal. All four sides are equal, so we can mold this we can mold this line in such a way opposite pairs of straight lines are equal and each interior angle is equal to 90 degree. So that means the definition of square satisfy the definition of rectangle. So all squares are rectangle, but all rectangles are square, that is not always true. All squares are rectangle, that is always true. Okay. So now you are able to figure out this thing very clearly, that the counting of rectangle in this figure is quite impossible in given time period. Because if you see, this is your rectangle, this is your rectangle. So this is also rectangle, 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 this is also rectangle. So there are several rectangles are there. There are several rectangles are there. So it is quite impossible to count rectangle in given time period. So it is not feasible. Feasible means it is impossible to count the rectangles in 30 second, 50 second or 2 minutes. It is impossible to count. So now we need to understand that how to count rectangles in this figure. So now we are going to discuss a trick that how to count rectangle in this figure. So what you need to do, you need to count or you need to write natural numbers starting from the rightmost smallest square like this in horizontal and vertical order 1, 2, 3, 4. This trick is applicable for what? Counting of rectangles. So first we need to write the natural number starting from the rightmost smallest square or rectangle. Okay, 1, 2, 3, 4. Similarly, we need to move in vertical order 1, 2, 3, 4. After writing all these number, we need to add these number. We need to add these numbers. So 4, 3, 7, 2, 9, 1, 10. Similarly, we need to add 4, 3, 7, 2, 9 plus 1, 10. And then multiply these two number. 10 into 10 will give you total 100. So how many rectangles are there? Total 100 rectangles are there. How many rectangles are there? Total 100 rectangles are there. Total 100 rectangles are there. A very good evening to Pradyuman. So 100 rectangles are there. So this is the trick that we use to count rectangles in such figures. Now, a question arises in our mind that how it works. How it works. And one more thing, in this 100, squares also included. Squares also included. Squares also included. Now I am going to discuss how this trick works. So the basic idea behind this trick is permutation combination, the concept of combination. So as you know, in math, in permutation combination, you learn about this concept that number of ways to select are things r things from n different things. Number of ways to select r things from n different things. N different things. N different things. And that is given by NCR. And that is given by NCR. And NCR means C stands for combination. C stands for combination. How many different combinations are there? C stands for combination. Okay, so C stands for combination. So NCR, this given by factorial n divided by factorial n minus r into factorial r. And what is the meaning of factorial? What is the meaning of factorial? What is the meaning of factorial? Factorial means what? For example, if I am taking factorial 5, factorial can be written as in this way or in this way also. Both are same, factorial. And factorial means what? We need to start with first natural number and multiply all these number. The product will give you the value of factorial. So this is 120. This is 120. This is 120. This is the value of factorial 5. For example, we are interested to find factorial 4. So we need to multiply 1, 2, 3, 4 till 4. So factorial 4 is 24. Similarly, factorial 3 is 1 into 2 into 3. So it is 6. Factorial 2 is 1 into 2. So it is 2. Factorial 1 is 1. And one more important thing here, factorial 0 is also 1. Factorial 0 is also 1. And one more thing you need to understand, factorial concept defined only for whole numbers. If someone asking what is the value of factorial minus 1, you will say the factorial concept is not defined for the negative numbers. Factorial concept defined only for whole numbers. So if we need to select r things from n different things, so how many different ways are there? NCR. It is given by NCR, factorial n divided by factorial n minus r into factorial r. Okay. Now in this case you are able to see, if we are discussing the same example again, no, I am discussing the idea behind this trick. So the question comes in our mind, how we can form a rectangle in this figure. Now if we are selecting two horizontal line and two vertical line at the same time, if two horizontal line and two vertical lines, two different horizontal line and two different vertical line, good evening NK, how are you? So if we are selecting two horizontal line and two vertical line at the same time and placing each other, so if for example I am selecting this straight line and selecting this straight line and selecting this straight line and selecting this straight line, the figure enclosed in these four lines is nothing but your rectangle. Got it or not? Got it? So this is your rectangle. So what we need to do to form a rectangle, what we need to do to form a rectangle, we need to select we need to select two horizontal, and two vertical lines at the same time. So how many straight lines or how many horizontal lines are there? How many vertical lines are there? How many horizontal lines are there? So horizontal lines are there. How many horizontal lines? So 1, 2, 3, 4 and 5. So 1, 2, 3, 4 and 5. So 5 horizontal lines are there, and we need to select 2 horizontal lines. So how many different ways are there? 5C2. So now you can see we are using the concept of permutation and combination. Now similarly, how many vertical lines are there in this figure? How many vertical lines are there in this figure? So 1, 2, 3, 4 and 5, and we need to select 2 vertical lines. Now we need to select horizontal and vertical line at the same time. So the concept of multiplication says in a permutation and combination, if we need to perform 2 actions at the same time, so how many ways are there to perform these 2 tasks at the same time or simultaneously? So if there are m ways to perform the first task number 1, and if there are n ways to perform task number 2, and we need to perform these 2 tasks in succession. For example, if task 1 is done, then we need to perform task 2. In that case, the number of ways is given by m into n ways. So we need to multiply the m ways by the n ways. So we need to select the horizontal lines, we need to select the vertical lines. So how many ways are there to select the horizontal and vertical lines at the same time in a succession? So we need to multiply these 2 ways. You will get the total number of ways. Now 5C2 is given by what? So as I told you, the formula of NCR factorial n divided by factorial n minus r into factorial r. Now you are able to see the formula. Now try to apply this formula and try to figure out what will be the product of these 2 numbers. Giving you 90 seconds to figure out. Try to figure out how many ways are there. So answer will be same. Answer will be 100. So if you are solving the 5C2, so 5 is your n, so factorial 5 divided by n minus r. This is your n, this is your r, so 5 minus 2. And factorial r, so this is 2. So factorial 5 is 120, factorial 3 is your 6, and this is 2. So similarly here also, factorial 5 divided by factorial 5 minus 2 into factorial 2. So 120 divided by 6 into 2. So you will get 10 into 10, that is your 100. So this is the whole idea behind this trick. Now you are able to understand the trick and at the same time the concept also of counting of rectangle. In exam we need to use this trick, but whenever you are using the trick, you know that you will feel that I knew the concept also behind this trick, and that will give you a confidence. Okay, so try to find number of rectangles. Try to find number of rectangles in next question. Find number of rectangles in given figure. Try to find number of rectangles in given figure. How many rectangles are there? So there are basically three questions: number of rectangles, second one is your number of square, and third one is your number of rectangles that are not square. Number of rectangles that are not squares. So try to figure out all these three questions in 2 minutes. Giving you 2 minutes to figure out. Let's see number of rectangles. So yes, NK, if we are counting the number of rectangles, that means squares are also included. Squares are also included. So we need to use the same trick as I discussed. We need to write the natural numbers starting from the rightmost smallest rectangle 1 2 3 4 5 and 1 2 3, and then add all these numbers. So you will get what? This is what? 15, and this is your 6. So 15 into 6, that is your 90. So total 90 rectangles are there. Very good, NK. 90 rectangles are there. Now number of squares. So how to count number of square in this figure? As I already discussed, we need to count number of squares in horizontal order and vertical order, or we can say number of smallest square in horizontal order and vertical order. So total 5 number of smallest square in horizontal order, and total 3 number of square in vertical order, 5 and 3. And then we need to subtract 1 from both the numbers. So you will get 4 into 2, then subtract 1, it will become 3 into 1. And now if I subtract 1 from 1, it will become 0, so we need to stop here. And then add all these numbers, 15 plus 8 plus 3. So it will 26. So total 26 squares are there. Total 26 squares are there. So in 90 rectangles, you know one thing very clearly, that squares also included. Squares also included. Squares also included. Now he is asking number of rectangles that are not squared, so we need to subtract the number of square from the number of rectangles, and you will get such kind of rectangles that are not square. So subtract 90 from 26. So you will get 64. So there are 64 rectangles are there which are not square. Only rectangle. Only rectangle. Now I hope the concept behind counting of rectangle and squares is crystal clear. Yes or no? Please tell me in comment box. Yes or no? Now, as we discuss the counting of rectangles, and as you know, the parallelogram is same as rectangle. The difference is what? Each interior angle is not equal to 90 degree. Remaining things are equal, or remaining things are same in rectangle and parallelogram. So the process of counting of parallelogram is same as the process that we use in counting of rectangle. So now we are going to discuss the type number 4, type number 5th, that is your counting of, type number 5th, that is your counting of parallelogram. Counting of parallelogram. Okay, and as I told you, we can write in form of note, process of counting of parallelogram is same as process that we used in counting of rectangle. Counting of rectangle. Now if I am asking, try to find how many parallelograms are there in this figure. So try to figure out how many parallelograms are there. And as you can observe one thing very clearly, that I formed this diagram in tilted way, because in parallelogram each interior angle is not equal to 90 degree. So you are able to see these two lines are not intersecting each other at a right angle. These are intersecting each other other than right angle. Yes or no? So if someone asking number of rectangles here, so my answer is 0, because there will be no such kind of rectangle or no such kind of figure that seems like rectangle. So now number of parallelogram. Now number of parallelogram. So as I told you, the process of counting of parallelogram is same as the process that we used in counting of rectangle. So try to write natural numbers starting from the leftmost smallest parallelogram 1, 2, 3, 4 and 1, 2, 3, 4 and add all these numbers. So you will get 10. Similarly, add all these number in vertical order also. You will get 10 and 10 into 10 will give you 100. So how many parallelograms are there? Total 100 parallelograms are there. 100 parallelograms are there. Very good, NK. Total 100 parallelograms are there. Total 100 parallelograms are there. Got it? Clear? Now I am giving you one more question. In this given figure, in this given figure, try to find number of parallelogram. So one thing you need to understand, in number of parallelogram, rhombus are also included. As I told you that square satisfy, as you know, square satisfy the definition of rectangle. So that's why in counting of rectangle, squares are also included. In similarly, the definition of rhombus is satisfy. Definition of rhombus satisfy the definition of parallelogram. That's why in counting of parallelogram we need to conclude, or we need to include rhombus also. Okay, so all rhombus are parallelogram, but all parallelogram are rhombus, not true. Okay, so rhombus are included in counting of parallelogram. So number of parallelogram we need to count. Number of parallelogram we need to count. Second, number of rhombus we need to count. Number of rhombus we need to count. And third one, number of parallelogram that are not rhombus. Number of parallelogram that are not rhombus. Try to figure out. So number of parallelogram, so we need to use the same process that we used in number of counting of rectangles. We need to write natural numbers starting from the rightmost smallest parallelogram. 1 2 3 1 2 3 4 5 and 6, and we need to add all these number, you will get 21, and 1 2 3 4. Similarly, we need to write natural numbers in vertical order and add all these number, you will get 10, and multiply both these number. Very good, NK. So 21 into 10 will give you 210, and as you know, rhombus also are also included. Rhombus are also included. Okay, now we need to count the number of rhombus. So as you know, the number of rhombus, the counting process of number of rhombus is same as the counting process that we used in a counting of a square. Okay, so how many squares, how many rhombus, how many small rhombus are there? The smallest rhombus are there in horizontal order and vertical order, 6 and 4. 6 and 4. Then subtract 1 from both the number, 5 into 3. Repeat the same process, 4 into 2 and 3 into 1. Now this 1 will become 0, so we need to stop here and multiply all these number. So 6 into 4, 24, 15, 8 and 3. Okay, 15, 8 and 3. So total how many squares are, how many rhombus are there? So total 26 plus 24, so 50 rhombus are there, and these 50 rhombus are included in 210. Yes or no, NK? These 50 rhombus are included. These 50 rhombus are included in 210 parallelogram. So we need to subtract to get those parallelograms that are not rhombus. So final answer for third question, 210 minus 50. So 160 parallelograms are there that are not rhombus. Now I hope you are able to understand this concept very easily, and now we can say counting of a straight line, counting of a square, counting of rhombus, counting of rectangle, counting of parallelogram are done. Yes or no? Yes or no? So counting of 5 figures we already done, and each and every concept is crystal clear. Please tell me in comment box yes or no. Now we are moving forward for the next concept, counting of diagonals. The sixth one is your counting of diagonals. Moving forward for the next concept, counting of diagonals. Type number 6, counting of diagonals. So counting of diagonals, if we are interested to count diagonals, so first we need to understand that we are counting diagonals, but in which figure? So we are counting diagonals in any type of polygon. Any type of polygon. And polygon is what? Polygon is a closed figure which is formed with the help of finite number of straight lines. Polygon is what? Polygon is a closed figure. Polygon is a closed figure formed with the help of finite number of straight lines. Finite number of straight lines. finite number of straight lines. Finite means that number we can count. That number we can count. So some student says that circle is a polygon or not. So my answer is circle is not a polygon. Why? Because circle having infinite number of straight lines. If we are going to draw the circle, so you can see these dot. These dots are considered as straight line. If we zoom this figure, you will see this dot will work as a straight line. So there are infinite number of straight lines are required to draw the circle. That's why circle is not a polygon, because in a polygon finite number of straight lines are there. Finite number of straight lines. So circle is not a biggest polygon. This is myth. Okay, circle is not a biggest polygon. Now, what is the smallest polygon? What is smallest polygon? So smallest polygon is your triangle having 3 sides. The smallest polygon is your triangle having 3 sides. So minimum 3 straight lines are required to form a closed figure. With the help of 2 straight lines, we are not able to draw a closed figure. So at least 3 straight lines are required. So the smallest polygon is what? Your triangle. The smallest polygon is what? Your triangle. So now you are able to see in a triangle there are 3 straight lines, and you are able to see this is your closed figure formed with the help of straight lines or finite straight lines, finite number of straight lines. Now what about diagonals? Diagonal is what? Diagonal is what? A straight line that can be formed with the help of the vertex of polygon other than the periphery and the straight lines that required to draw the periphery. What is diagonal? Diagonals are the straight lines that can be formed by joining the vertex of a polygon other than the straight lines that are used to draw the periphery. So other than the straight line that are used to draw the periphery. So other than these 3 straight lines, if we are able to draw another straight line using these vertex, connecting these vertex, so that kind of line is known as your diagonal. For example, if we are taking a quadrilateral, so you know that in a quadrilateral there are 4 sides. There are 4 sides required to draw the periphery, and these are the vertex. These are the vertex. These are the vertex. So as I told you, diagonal is what? The straight line that can be formed by joining the vertex of the figure by joining the vertex of the polygon other than the straight lines that are used in forming the periphery of figure. So other than these 4 straight lines, if we are able to draw some more straight lines with the help of this vertex, that are considered as your diagonal. So now you are able to see, if I am joining these 2 vertex, there is one more straight line we can form. And similarly, if we are joining these vertex, there is one more straight line we can form. So how many diagonals are there? How many diagonals are there? So in this figure, 2 diagonals are there. In this figure, we are not able to draw such line other than these 3 straight lines. So in that case, in triangle, diagonal is equals to 0. Diagonal is equals to 0. Now, if I am drawing a pentagon, so pentagon is having 5 sides, So try to figure out how many diagonals will be there in pentagon by your conventional method. By conventional method, try to find how many diagonals are there in pentagon. Giving you 60 seconds to figure out how many diagonals are there in pentagon. Try to figure out. So yes, NK, very good. Total there are 5 diagonals are there. You can see this one is your first, second, this one is your third, this one is your fourth, and this one is your fifth. So total 5 diagonals are there. 5 diagonals are there. Now moving forward for the next figure, that is your hexagon, and hexagon you know having 6 sides. Now again try to figure out how many diagonals are there in this figure. After that I will discuss the trick. With the help of this trick we can find the number of diagonals in 30 seconds. But before, we need to understand, or we need to find or figure out how many diagonals are there in hexagon. Try to find. So now you are able to understand this thing also. As the number of sides are increasing in a polygon, counting of diagonal become more difficult. Yes or no? So now if we are counting the number of diagonal in this figure, so let's see how many diagonals are there from this vertex 1, 2 and 3. Total 3 diagonals we can draw. Total 3 diagonals we can draw from this vertex. Now this 4, or using the different color, 4, 5th and 6th diagonal. Okay, 6 diagonals. Now from this 7, 8, and this one is already we draw. And now from this first, second, and this one is your also. Now all the diagonals we have found. So total how many diagonals are there? Total 9 diagonals are there. So in hexagon how many diagonals are there? Total 9 diagonals are there. Now I am going to tell you the trick. By using this trick you can find the number of diagonals in 30 to 40 seconds. So number of diagonals is given by n into n minus 3 by 2. N into n minus 3 by 2. Here n is number of sides in diagonal, in polygon. Number of side in polygon. Okay, so let's discuss the same example here. Here n equals to what? 6. So the diagonal will be what? N is equals to 6. 6 into 6 minus 3 divided by 2. So 6 into 3 divided by 2. So it will give you 9, and you are able to see the same number we are getting here. So total 9 diagonals are there. Similarly in pentagon. In pentagon n equals to what? 5. So apply the same formula for diagonal. 5 into 5 minus 3 divide by 2. So you will get 10 divided by 2 and that is your 5. So we are getting the same number. Yes or no? We are getting the same number. Here also, here n equals to 4. So 4 into 4 minus 3 divided by 2. So you will get 4 into 1 divided by 2, that is 2. So we are getting the same number. And similarly, here also n equals to 3. So 3 into 3 minus 3 divided by 2. So 3 minus 3 will become 0, 0. So we are getting the same number. Now with the help of this formula, we can count the number of diagonals in 30 seconds in any polygon. In any polygon we can count the number of diagonals. I hope you understood very well. So now if someone asking how many diagonals are there in decagon? How many diagonals are there in first decagon, second octagon, third one is your nanogon. Try to figure out number of diagonals in these polygons with the help of this formula. Very good, NK. Try to figure out number of diagonals in these figures. Very good, NK. So you know that in decagon how many sides are there? N equals to 10. So diagonals 10 into 10 minus 3 by 2. So 10 into 7 divided by 2, that will be 35. So in decagon 35 diagonals are there. In decagon 35 diagonals are there. Similarly, we need to count number of diagonals in octagon. So in octagon n is equals to 8. Number of sides are 8. So the diagonals are 8 into 8 minus 3 divided by 2. So 8 into 5 divided by 2. So that is your 20. So 20 diagonals are there in octagon. 20 diagonals are there in octagon. Now similarly, in nanogon n equals to 9. So diagonals is what? So number of diagonals is what? So 9 into 9 minus 3 divided by 2. So 9 into 6 divided by 2. So that is equals to 27. Not 26. It will be 27. I think NK, there is some kind of calculation mistake. It will be 27. Okay. So 27 diagonals are there in nanogon. Now you got an idea how to count number of diagonals in any type of polygon. Just remember the formula n minus 3 by 2. Here n is number of sides. Understood? Now moving forward for the type 7 that is the simplest type, counting of circle. Usually not asked in exams. Counting of circles. Counting of circles. So now in counting of circle, as I told you, this is the simplest type and not asked in exams on the regular basis. So basically we need to count how many how many circles are there in this figure. So I am drawing different circles, arranging so in case of circle, if two circles intersect each other, so in that case it will not form any new circle. If two circles intersect, it will not form a new circle. So that's why the counting of circle becomes very easy. Why it is a simplest type? Because intersecting of two circles will not form a new circle. Now someone asking how many circles are there. So basically this is the figure you can see, and you need to count how many circles are there. Basically you need to count all the circles one by one. As you can see, this one 1, 2, 3 plus 1, 2 and 3 plus. Now we need to count the circles that are arranged in a circumference of these two circles or circumferential order. So starting from this 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 circles are there. Now for this, starting from this circle 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 and 14. So 14. None other than these circles, none other than circles are there. Okay, so total how many circles are there? 14 plus 9, 23, 26, 29. So total 29 circles are there. No circle will formed with the help of two circles or intersection of two circles. There will be no new circle will form. That's why the counting of circle is the simplest type among all them. Okay, so now I hope you understood how to count circles. Less important with respect to your exam. Okay, so now moving forward for the next and the final type that is very important regarding to your exam, that is your counting of triangles. As you are able to see, counting of circles also done, counting of straight line, square, rhombus, rectangle, parallelogram, diagonal, circles all done. What remains? Counting of triangles. Counting of triangles. So now we are going to start counting of triangles. Type number, the final type number 8, that is your counting of triangles. Type number 8, counting of triangles. So in counting of triangles, there are some basic figures that counting we need to understand. There are some basic figures, and the first basic figure, if a triangle having some lines that are executed from the one vertex and drawn to the opposite side, and if we are asking how many triangles are there, for example, in this figure how many triangles are there, in this figure how many triangles are there, so total how many triangles are there we need to figure out. So the trick behind this counting of triangle, what we need to do, we need to write the number on the base 1 2, and we need to add all these number, you will get 3. So there are total 3 triangles are there in this figure. First one you are able to see this. First one is this. This is the first triangle, this is the second triangle, and third one is the largest. So total 3 triangles are there. Total 3 triangles are there. Similarly, if we need to count the number of triangles in this figure, write down the number, the natural number on the base starting from this 1 2 3, and add all these number, and you will get the total number of triangle in this figure. And you will get the total number of triangle in this figure. This one is your first triangle, this one is your second triangle, this one is your third triangle. First see these 3 triangles. Now this one is your fourth one, and this one is your fifth one. Okay, so these are 3 triangle, 3 smallest triangle, 2 triangles that I told you, and now the final one is your the biggest triangle 1. So total how many triangles are there? Total 6 triangles are there. So in a next question we need to use the same process 1 2 3 4. So add all these number 1 plus 2 plus 3 plus 4. So total how many triangles are there? Total 10 triangles are there. Total 10 triangles are there. So this is the case first in which we draw a straight line from any vertex of a triangle to the opposite straight line. To the opposite straight line. Okay? Clear? So now moving forward for the next case. Case second. Now for example, if I draw a parallel line also in this figure, we draw a line from the vertex to the opposite side. Now we introduce one more line that is parallel to the base. Now I am asking how many triangles are there in this figure. So try to figure out how many triangles are there in this figure. Similarly, how many triangles are there in this figure? Similarly, how many triangles are there in this figure? How many triangles are there in this figure? So now I am going to tell you the trick required to count number of triangle in that kind of figure. What you need to do, you need to write the same numbers on the base 1 plus 2, that will be 3. Now count number of bases. So total how many bases are there? Total 2 bases are there. Total 2 bases are there. So now multiply this 3 with 2, you will get 6. So total how many triangles are there in this figure? Yes, very good NK, total 6 triangles are there. How many triangles are there? Total 6 triangles are there in this figure. How many triangles are there? Total 6 triangles are there in this figure. Similarly, if we need to count number of triangles in this figure, so how many triangles are there in this figure? So try to figure out how many triangles are there in these two figures. Try to figure out. So very good NK. So what we need to do, just write the natural numbers on the base. 1, 2, 3, add all these number, 1 plus 2 plus 3, this is 6. Now count how many bases are there, because each base will provide, or each base will introduce new triangle. For example, if I am drawing this base, or if I am introducing this base, so due to this base you can see this triangle, these types of triangles are formed. So total how many triangles are formed? 1, 2, 3, 4, 5 and 6. Total 6 triangles are formed due to this diagram. Similarly, due to this base, how many triangles are formed? Due to this figure, or due to this base, how many triangles are formed? So 1, 2, 3, 4, 5 and total 6 figures are there. Total 6 figures are there. So total, each base will provide you total 6 triangles. So how many bases are there? 1, 2, 3, 6 into 3, so total 18. So total 18 triangles are there. Okay. Similarly, for this figure, 1, 2, 3, 4. So 1 plus 2 plus 3 plus 4. So total 10 triangles are there on each base. And now how many bases are there? 1, 2, 3, 4. 1, 2, 3, 4. So 10 into 4. 40 triangles are there. 40 triangles are there. So very good NK. In second 18 triangles, in third figure total 40 triangles are there. So now you are able to understand this case also. Now we are discussing the case third in same counting of triangles. If we draw such kind of figure, so how many triangles are there in this figure? So how many triangles are there in this figure? So I am going to tell you the trick. 1, 2, 3, 4 and just double this number, you will get the number of triangles inside this. And now I am going to tell you all these 8 triangles. This one is your first, second, third and fourth. These 4 triangles are clearly visible. Now remaining 4 triangles that are not clearly visible are known as your hidden figure. Hidden figure. That's why the counting of triangles is always challenging for a student. Always challenging for a student. Why? Because there are some hidden figures also there. In counting of circles, There is no such space for the hidden figure, so that's why counting of circles is simplest type of counting. But in triangles, some triangles are hidden. We need to figure out that hidden figure. We need to figure out that hidden figure. So now you are able to see this one, this triangle and this triangle. These two triangles are not counted. And similarly these two triangles also. And similarly these two triangles also. So these four triangles are hidden figures. So total how many triangles are there? Eight triangles are there. 8 triangles are there. 8 triangles are there. Similarly, if I am taking this figure and if I am drawing one more line here, now how many triangles are there? How many triangles are there? So 1, 2, 3, 4, 5 and 6, and we need to double this number. So 6 into 2, 12 triangles are there. See, these are all these are basic figures. What is meaning of basic figure? Basic figures are those figure, the counting of that figure we can perform in 30 or we can say 10 to 15 seconds. Basic figures are those figures that counting we can perform in 10 to 15 seconds. Or we know the trick how to count the number of figures in 10 to 15 seconds. That is known as your basic figure. So in exam there will be question can directly put from these figures, or what can happen, a question or a diagram can be formed with the help of two or more different basic figure, or can be formed with the help of same basic figure but in repetition. For example, you can see if I draw this figure and if I am asking how many triangles are there, so you can see in this figure we are using two same basic figure. We are using two same basic figure. So this figure will contain 8 triangles. This figure will contain 8 triangles. So now you are able to see with the help of the basic figure concept, we can count the 16 triangles in 10 to 15 seconds. Now remaining 30 to 40 seconds we need to spend to find out the hidden figure. Remaining 30 to 40 seconds we need to spend to find out hidden figure. So now you are able to see in this 8 triangles, after that you are able to see this triangle is not counted because this triangle is formed due to combination, or we can say due to the arrangement of these two basic figure. And similarly there is one more. There is one more. So there are two hidden figure. So total 18 triangles are there. Total 18 triangles are there. Total 18 triangles are there. So basic figure will help you. Basic figure will help you to count such triangles or such figures, such triangles that are formed with the help of basic figure in 10 to 15 seconds. Remaining 30 to 40 seconds we need to spend to find out the hidden figure. So total 18 triangles are there, not 16. Okay. Similarly, in this figure, if I draw one more line, here, so now how many triangles are there in this figure? So I can apply the same thing, starting from 1, 2, 3, 4, 5, 6, 7 and 8. Last number is your 8. 8, 2 times of 8 will give you 16. So how many triangles are there? 16 triangles are there. 16 triangles are there. But it doesn't mean if someone giving you such kind of diagram and if he is asking how many triangles are there, and if you are doing this thing 1, 2, 3, 4 and 4, 8, 8, this is sin, because there will be no triangle is there, because the lines you can see, we draw a horizontal and vertical line, there will be no triangle will formed Here only square will form, or we can say rectangle will form. So not, there will be no triangle. So remember one thing, these line must be drawn in a diagonal form. These line must be formed in a diagonal form. First these two lines must be formed in a diagonal form, then if you added one more line or two more line, you can apply the same concept. But if you are drawing the two lines in horizontal and vertical form, then there will be no triangle will form. Okay, so remember this thing also. Now if you are able to see this question, and if someone asking how many triangles are there in this figure, so we can apply the same concept, because you can see two lines are formed or drawn in a diagonal form, and then there is one and two lines are also formed. So how many triangles are there? We can apply the same trick starting from the 1, 2, 3, 4, 5 and 6. Now double of 6 will be 12. So total 12 triangles are there. So total 12 triangles are there. How many triangles are there? Total 12 triangles are there. Got it? How many triangles are there? Total 12 triangles are there in this figure. Yes or no? I hope you understood very well. Okay. Now case number 4. Case number 4 regarding to your star figure. So if I am drawing two stars, so try to figure out how many triangles are there in these two squares, in these two stars. How many triangles are there in these two stars? Try to figure out how many stars are there, sorry, how many triangles are there in these two stars. Will be same, will be different? Tell me. So in the first figure, you can observe there are only 8 triangles are there. There are only 8 triangles are there. 1, 2, 3, 4, 5 and 6. 6 is small and 2 the bigger one. 1 and 2. So total 8 triangles are there. So in this star total 8 triangles are there. Now in this star how many triangles are there? So 1, 2, 3, 4, 5. 5 small triangles. 5 small triangles. Now need to observe very carefully. There are 5 more triangles are there. This is your first one. This is your second one. So you are able to observe these 2 triangles. Now I am going to tell you the third one. You are able to see this third one. This is your third triangle. Now this is your fourth one, and this is your fifth one. So total 5 hidden figures are there. Total, how many hidden figures are there? Total 5 hidden figures are there. So 5 plus 5, total 10 triangles are there. So total 10 triangles are there. How many triangles are there? Total 10 triangles are there. Got it or not? Got it or not? Total 10 triangles are there. Able to understand or not? Able to understand or not? So 8 plus 10, total 10 triangles are there. So try to figure out how many triangles are there in this figure. Try to figure out how many triangles are there. Number of triangles in this figure. Number of triangles in this figure. Try to figure out how many triangles are there in this figure. How to know the hidden figures? NK, we need to practice more and more. First you need to understand all the basic figure. After that you need to perform about 50 to 60 questions or 70 to 80 questions of counting of figure. After that you will get a confidence and you are able to find the hidden figures. Okay, so first you need to understand the all basic figures that will reduce your time during counting of triangles, and then after you need to practice about how to find the hidden figures. Okay, so I think if you solve 70 to 80 questions, after that you will get a confidence and automatically you will see the hidden figures. Okay, so now you are able to see 1, 2, 3, 4 and 5. Total 5 triangles are there and one more triangle is here. This one is also. No other such triangle is there, so total 6 triangles are there. So 6 is the correct answer. 6 is the correct answer. 6 is the correct answer. I hope you understood very well. Okay, so now moving forward for the next case, case number 5th. Case number 5th. If someone asking how many triangles are there in this figure, if I inserted an inverted triangle in the given triangle. So due to the inverted triangle, how many new triangles are formed? So due to this inverted triangle, how many new triangles are formed? So you are able to see due to this inverted triangle 1, 2, 3 and 4. Total 4 new triangles are formed. Total 4 new triangles are formed. Total 4 new triangles are formed and one triangle. This is already exists. So total 4 plus 1, 5 triangles are there. So an inverted triangle always introduce 4 new triangles. If there are 2 inverted triangle, it will introduce 4 into 2, 8 new triangles, and one that is already exists, so we need to add one at the end. Okay, so for example, if someone asking how many triangles are there in this figure, if someone asking how many triangles are there in this figure, so try to figure out how many triangles are there. How many triangles are there in this figure? How many triangles are there in this figure? So total how many triangles are there? Nk, at the end we need to add one also, na? Due to this, the biggest triangle we need to one also, na? Due to this inverted triangle, how many triangles, new triangles will be formed? 4. So there are total 2 inverted triangles. There are 2 inverted triangles. So due to this 2 inverted triangle, 4 into 2 new triangles will be formed, plus at the end we need to add 1 also due to the biggest triangle. So total how many triangles are there? 9 triangles are there. 9 triangles are there. Got it? So how many triangles are there? 9 triangles are there. So try to figure out how many triangles will be formed in this figure. How many triangles are there in this figure? So as you are able to understood this thing very clearly, that we have discussed lot of basic figures regarding to the counting of triangles, counting of squares, counting of rectangle, rhombus, diagonals, all the types that I wrote initially in the first slide. I have discussed all the types in this class. Yes or no? And I hope you enjoyed the session, you understood all the things, all the concepts, all the tricks, and the reason behind the tricks. Yes or no? Please tell me in comment box. So as you can see, how many inverted triangle are there? 1, 2, 3 and 4. 4 inverted triangles are there. 4 inverted triangles are there. 4 inverted triangles are there. And due to one inverted triangle, how many triangles will form? Total 4. So due to 4 inverted triangle, how many triangles will be formed? 4 into 4, 16. And at the end we need to add 1 also due to the biggest. Due to the biggest. So 16 plus 1, how many triangles are there? Total 17 triangles are there. Total 17 triangles are there. Total 17 triangles are there in this figure. I hope you understood very well. Got it? Similarly, if I am asking how many triangles are there in this figure, so try to figure out how many triangles are there in this figure. How many triangles are there in this figure? How many triangles are there? So in this figure you can see 8, in this figure 8, and in this figure 8. So basic figure gives an idea to count triangles in 10 to 15 seconds. So 8, 16 and 24. Now remaining 40 to 50 seconds we need to spend to find the hidden figures. So now you are able to see first and second, 2 hidden figures, and similarly 2 more hidden figures. First one is this and second one is this. So total 4 hidden figures are there. So 16 and 24, 26 and 2, 28. So total 28 triangles are there. Total 28 triangles are there. Okay. So in this lecture we have discussed the figure calculation, and in figure calculation there are total 8 types, and in this class we have discussed all these 8 types: straight line, square, rhombus, rectangle, parallelogram, diagonals, triangle and circles. I hope you understood very well. I hope you enjoyed this session. So after this class you can revise this session or you can make your notes Okay, so if you love this session, please like and share. Thank you so much.